Cessna 11746 executive tower, make a straight in runway 20.
Straight in runway 20746.
Hi there, I'm Heather Armstrong. I'm the chief pilot at the BL Aero Club. I'm here with a couple of our instructors, Brian and Luca. We're here in sunny California to show you a couple of systems on some of our aircraft. We'll start here with our Piper Warrior and we'll transition over to our Cessna. So here we're standing at the Piper Warrior. We're just going to go over some just kind of components that you'll find on a small general aviation aircraft. At the front of the airplane we've got the cowling, which houses the engine and its accessories. Followed by the main body of the airplane, which is referred to as the fuselage. In the very back, we come to the empennage, which is your vertical stabilizer and your horizontal stabilizer. The Piper Warrior comes with a low wing configuration. Something to note is in the wings is where we have our fuel tanks. So there's a fuel tank in the left wing and a fuel tank in the right wing. Our other training aircraft, the Cessna 172, has a high wing configuration.
Now we are in the cockpit of the Piper Warrior, and we're going to have a look at the flight controls. This here is the yoke, and when I pull on it, it moves these cables that are connected to the elevator surface. When I turn the yoke to the left and to the right, the cables that are connected to the ailerons are being moved. Here we have the flap lever. When I pull up on this, it goes through this different flap settings. Pushing down on this knob at the top of the lever lets me retract the flaps. These ones are the rudder pedals. They are connected to the rudder control surfaces. The pedals also help us steer the airplane when we're taxiing on the ground.
Let's transition into the Piper Warrior power plant. As you can see, I'm opening up the cowling here, and in here you can see the engine compartment or the power plant. Per the POH, we should have an O320 in here, and as we can see, each engine power plant has a data plate on it. And as you can see right here, this one says it's an O320. Now what does the O320 mean? For one, O meaning it's opposed, and the lack of an I meaning that is carbureted engine, not a fuel injected engine. The 320 has to do with the amount of cubic displacement that the engine makes. This being a 4-cylinder engine, each cylinder, if you do our math, 320 divided by 4 should be 80 cubic inches of displacement, meaning that's how much air or air fuel it moves. It's indicative of how much power this engine makes. When I am teaching on this power plant, I use the L-hand model. Lycoming, being the L of the L-hand, horizontally opposed, meaning that the cylinders are 180 degrees away from each other, so 2 and 3 might be opposed from 1 and 4. The A is air-cooled, meaning that there's no coolant inside this engine that's providing cooling. It's just the air flowing through these cooling ports, directed by the baffling to cool the engine. Also the cylinder having fins on it to help display or dissipate the heat that is created by the combustion. Normally aspirated, meaning there's no turbocharger or supercharger that's pumping up the air pressure inside that's delivered to the engine. It's just whatever the normal air pressure is going in and being used by the engine. And D being direct drive, meaning the prop is actually just an extension or extended and attached to the crank itself, the crankshaft. If we look, each cylinder here has 2 spark plugs. If we follow these spark plugs, there's one on top, one on the bottom. If we follow them back, they go to these magnetos back here. There's a left and a right magneto. And these are just for redundancy in case one of them was to fail. We would still have spark to the cylinders and be able to run the engine. Now the special note on the magnetos is the engine is a closed system. It doesn't need a battery to run. It doesn't need the alternator to run. If those were to fail, the engine would still run. We would lose all electrical in the airplane, but the engine would still be running. As long as the engine's turning, the magnetos are directly geared to it, the magnetos should be firing and the engine should be running. As we follow back here, we have the oil dipstick that goes down into the oil pan. This is a wet sump system, meaning that the oil is contained within the engine, as opposed to a dry sump where there's an oil reservoir off-site from the engine. We also have an oil filter and an oil cooler in the back where air goes and passes through and cools the oil. Oil is important because it lubricates and it also cools our engine. As we said before, there's a carburetor on this engine, and as you can see down here, the carburetor is hooked to this air box. Air comes in from the scoop here. This is where we could add our carb heat if we needed to, if there was maybe a problem of icing in the carburetor. But here in sunny California, we rarely have that problem. And this is where the air and the fuel is mixed in the carburetor, and that is delivered through the intake manifold into the intake pipes and delivered to our cylinders. From there, the combustion process happens, and then the exhaust pipes help to direct the exhaust gases away into the exhaust manifold and out of the airplane. As we move to the other side of the engine, the left side, you can see we have the cooling port here, and as you see, the baffling directs the air right to the oil cooler. The oil cooler acts like a radiator in your car. Oil runs through these pipes. They have fins on it. As the air passes, the hot oil exchanges the heat, and as the oil moves through, it cools down. Oil provides lubrication and cooling for the internal parts of the engine. And now we've transitioned to a 172 cockpit. As you can see here, we have our master switch and our ignition switch. The master switch controls the battery master bus, which is hot when we turn this on, and it controls certain things like lights, the ignition switch as we turn this on, and a few other items. I have the key here. This is kind of where the key goes. Yes, planes do have keys. As we turn on, I'm not going to actually turn this on, but as we move through, you can see there's an off position, a right position, left position, both, and then a start position. As I turn the key through the right, left, and both, these are actually turning on, as you can see here, the magnetos. It's ungrounding the magnetos and making them hot. So if we were to turn the prop, it would actually build up an electrical charge inside the magnetos and be firing the spark plugs as they discharge. If I go all the way to the start position, that's going to send a power from the battery to the starter, much like your car would start. Now that starter is going to get the full brunt of the battery power, and that starter is going to send out a little gear which contacts the flywheel on the engine itself, which is directly connected to the crank and turns over the engine. We also have, as part of the battery master side, we also have an alternator side in which we can turn on and off the alternator and disconnect it from the circuit. Now as we turn that key to the start position, battery power is sent to the starter. That starter motor begins to turn. A little gear comes out, contacts the flywheel, which is mounted to the crankshaft. As that flywheel starts to turn, it turns the engine over. The magnetos fire because they're already hot, and then we have mixed with fuel, we should have an engine that starts. On the 172, the alternator is right here. It is belt driven, much like your car, so as the engine turns, the belt turns, the alternator. The alternator provides battery charging and runs all the electrical systems in your airplane. Now, how do we make sure that we comply with aviates as PIC? Well, the way that we do that is we look at the maintenance logbooks that we have here. So for this plane, if we want to find the annual, we're going to have to look in the airframe logbook and see which date that was. And looks like this right here is our annual inspection for the airframe. There will be a companion engine annual sign-off and a prop annual sign-off. So we'd check in here and we'd see the annual was done, and it was done by the properly rated certified mechanic. on this date, and we should see the same dates inside the engine logbook as well as the prop log.
So during a ground school, you are going to learn about the airplane systems in general. Now, what is really important to know for you is how the systems of your particular airplane work. And where you learn about this is your pilot's operating handbook, or POH. And this document needs to be on board of the airplane whenever you go flying. I took it out of the airplane just to go over it with you here real quick. What this is basically a manual for your specific airplane. It tells you about the limitations you have or your airplane has, about some procedures, performance, and also it has a detailed description of all the different systems in your airplane. It is really important that you know and that you're familiar with how these systems work. This entire section here on systems tells you how these systems work, how you operate them, and what you do in case you have any malfunctions. Because unlike in a car, you can't just pull over and figure out what the problem is. When you're in the air and something is going on, you really need to know what you do. So make sure you study this and know what is going on with your airplane.